Hello, my name is Thomas Langer and today I will show you the use of Helidon DbClient. We will start with generating a project for Helidon SE. So let's go to our documentation. We will choose Helidon 2 and in the Helidon SE section we will go to Guides and our Quick Start. Here you can just copy the maven command that will generate a project for your environment. I've already prepared this before I started this recording, so let's have a look on what needs to be done to use a DbClient. So the Quick Start service is a simple service that returns hello world or hello and a name that you send in, and we will update this service to actually call the database to retrieve what to return for each request. So first thing that we need to do is to add dependencies on Helidon DbClient. And I will explain each one as we go. So first you add a dependency on the API of the DbClient. This is a set of APIs that are the same independent on the database that you use. We currently support any JDBC database or Mongo reactive driver. So that's the second dependency you can see here. I will be using a JDBC driver in this example. If I replace the JDBC with Mongo here, we would be using the Mongo reactive driver. Of course, when you use JDBC, you need to also add an actual JDBC driver for a database of your choice. In my case, I'm using the H2 database, and I have chosen our DB driver wrapper that we have in Helidon because that supports native image ahead of time compilation. We also have such a driver for Oracle DB. In addition to that, I have added two dependencies that are optional. So I have added support for health checks in Helidon, and I have added support for metrics in Helidon. We also have another library that supports tracing if you decide to use open tracing with Helidon. So that's the first step. We add these libraries to our class path so we can start using them. Second step, we need to add configuration. So in Helidon, we use application.yaml as the default configuration file if you use YAML, if you have YAML on the class path. So here I have added a section that is prefixed with DB. So first thing you do is you define which type of database you want to use. This is not mandatory, but we use it because you may want to have access to multiple databases. And if one of them is JDBC and the other one is Mongo, depending on the service loader is not sufficient. So you can actually explicitly say which source you want. After that, then this is specific for JDBC, we define the connection. Of course, the URL to the database, I will be using an H2 database that is running in a Docker image. And then we have the section of statements. You have an option to either define statements in your configuration or to define them directly in the source code. I prefer the way in configuration because then you can switch databases dialects as you want, and you just change your configuration. You don't need to recompile your source code. There are a few things I wanted to demonstrate here. First, if you use health checks, you need to define the ping statement. So I'm just setting a variable to a value for the H2 database. Then you can define any number of statements. There are just two things you can use for defining parameters. So first option, you define a named parameter. So if you do a prefix colon and then the name, you will need to specify a parameter of that name, and that will be used to execute a statement. Second option is to use ordered parameters. So each question mark is one parameter ordered as you define them in your statement. Be aware that the syntax is slightly different for MongoDB, because in MongoDB we cannot use the prefixes with colons. Okay, so we have prepared our database setup. Now let's go to our source code and create the database client and use it in our service. So I will start with the main class, where I will create the DbClient from configuration. So you can see here this will create an instance of DbClient based on the configuration in the DB section of our configuration. In addition to that, I have added a DbClient metric that will be a counter, and it will only be executed for statements that are named ping. So we will just see how many the ping statement was invoked. You can use other types of metrics as well, such as meter and timer. I have a smaller method that will create the tables, so it will just execute a DML statement that I have in my configuration called create table and wait for its execution. This is because we need to create the tables because we do the rest of the server. So we just block here even though it's a non-blocking API. And the next step is we use the DbClient in our routing. So I will go to the create routing method. And we have two changes here if compared to the quick start. So first is I have added a liveliness health check that is created from the DbClient health check. So here you can see how to add a health check for a DbClient, and that will automatically use the ping statement I talked about. And second change I did, I have actually updated my grid service to accept the instance of DbClient as well. So you can see the DbClient instance is shared by the whole environment. So finally, we get to the actual business logic of our solution. So I will start by showing the routing that I have added. So in the quick start example, you will have the get message handler, which is using a named parameter called name, and it just returns hello name by default. I have added here two new methods. I have added a put method for the same path and a delete method for the same path. So the put method will create a record in the database, and the delete will delete it. And I've updated the get method to actually use the database to obtain the greeting that will be returned. So now if I go to the get message handler, we can see quite a big change. So originally there was just let's get the name from the request and then send response. So now I will be doing a DbClient execution. So we can see here that I am creating a named get based on the name of the statement. And just to remind us, I will open the application.yaml again, and we can see here there is a select one statement that contains the actual JDBC. And this is using order parameters, so I just put a parameter after the statement name. Then when it finishes execution, it returns me an optional of a row. So if the row is present, I will send the response based on the value of the column called value, which I get a string. And if it's not found, I just return a 404 because it wasn't found. Then my update greeting in database, actually this should be insert greeting into database because we have a new greeting that will be inserted. So again, I get the name from the path, and then I said, give me the content from the request. So this will be the entity that we sent. And when we receive the entity, I will call the DbClient and tell it I want to execute the insert statement, and insert statement is using named parameters. So let me just switch back. We can see that it uses the name and the value named parameters. So I add them as named parameters and I execute the statement. And then when it finishes, I will send status created, or I will send an exception in case the execution failed. Very similar is the delete greeting in database. So I'm just using a named delete in this case, which has again ordered parameters. And in this case, I just say it's no content when I delete it. And again, if there is an exception, I just send the exception back. So that's the very quick introduction into how to use database in the source code, and now we can go and actually try it out. So I have my environment here. I also built a native image for it, so let's just for fun use the native image. I start my application. It's listening on the same endpoint as the quick start would listen, and now we can execute our commands. So let's start with our greeting, and if I do this, it will just return hello world because we didn't change the default greeting. And now if I try to request the named greeting, we get a 404 because there is no record in the database. So now we can insert into the database, and I will just say, let's put database client for the name YouTube. we got our 201 created. So now if I retry the same, I should get our hello database client, because it's doing hello and the content of the database. And of course I can delete it again. So I will do the delete command over HTTP. We get no content, and again if I try it, I should get a 404 because the record is no longer there. So we have showed the business logic of our application that is using a database, and now let's have a look on the health checks. So I will just do a health request, and we can see that the JDBC H2 named health check is up. And now if I request a metric, so the application metrics, we can see that the DB counter ping was invoked once. Of course, what I can do now, I can just stop the H2 database and execute our health check again. And now there will be a timeout because the database is not responding. So this really depends on the configuration of the database itself. Once the timeout finishes, we will see that the state is down, and we can see that there was a timeout exception on our call. So the database is not responding. And again, if I do our metrics, we can see it was only called once because the second time it failed to invoke because the database is down. So this concludes our example of a database. Thank you for listening and enjoy Helidon.